All right, recording is in progress. So thanks for joining us today for our webinar, where we're going to give you a look at the Creo Flow Analysis extension for Creo to do computational fluid dynamics, which is a really fun phrase to say. Our presentation today is going to be led by Paul Dye, applications engineer and solutions consultant at PTC. And we're going to take a closer look at this extension. There's actually, I think, 3 different offerings for Creo Flow based on what your needs are. So you don't have to buy a product that's, does too much, or also a product that may not do enough for you. At one point, we were a Mentor Graphics reseller and had sold Flow EFD. And one of the problems with that software was that it was like one size fits all. So it was pretty pricey and really expensive, and you got a lot of features. So what we found with Creo Flow is that it's every bit as good as Flow EFD. And also you have the options of getting a lesser expensive packages, which Paul will review at some point in the presentation. So if you have any questions, feel free to type those in the chat or the question and answer box, and we'll try to answer them as we go. So without further ado, Paul, and by the way, we should probably be about maybe 25 minutes today. So 25 to 30 minutes. So without any further ado, Paul, take it away, my friend.
Yeah, perfect. You can hear me okay, Rob?
I hear you loud and clear, and I can see your screen.
Awesome. Well, thank you again, Rob, for having me on, and thank you everybody for hopping on today. I might be a little biased, but I think this is probably one of, if not my favorite extension within Creo. I think it's one of the strongest things that we have available, especially for the people that need to use it. And like you mentioned, there's multiple different flavors of this. So people a lot of times look at flow analysis as something that is really outside the scope of what they would want to work with, or it's too expensive or too complicated. And Creo Flow Analysis is none of those things, right? It's extremely user-friendly and very strong to work with, and multiple different ways to get started into it. So that's what we'll do. I'm going to go ahead and really dive into it. If you really have any questions around this or anything that you want me to explain any more in depth, definitely feel free to drop that in the Q&A. I'd be happy to do that. If there's anything that I can't answer on the call today, then I can definitely reach out as well and get anything answered, reach back out. And with that, we can go ahead and dive into it. So first thing I like to do whenever I go through and start to talk to anything related to flow analysis is just start by looking at some of the challenges that people typically see whenever you want to work into this type of area. And computational fluid dynamics, or CFD, is typically seen as something that really requires extensive training or knowledge that your engineers, designers tend to lack. They're very good at doing the design work. They're very good at building out very robust models, but whenever it comes to looking at how they perform, especially from a flow analysis standpoint, it's just seen as something that's outside of the area of your standard expertise. And even to run this type of analysis really normally requires the use of third-party tools that are oftentimes not only very expensive, but at the same time, hard to use. That's because you have to take the models from your CAD environment. You typically have to export them, have somebody that has knowledge on how to use CFD tools to even begin into an analysis. It'd be a very time-consuming process from start to finish. Tends to make the process really only viable in the later stages of the design, because whenever you're in the development stages, your models are always in a constant state of change. You're adding new features, you're trying things out, and you don't have the time to wait around for analysis results. You don't have the time to send it over to an analyst who has to work with it for a week and get everything ready and then send you back results. And by that point, your design's probably already changed. So that's something that we see as challenges for a lot of different people out in industry. And these are all things that we set out to solve using Creo's flow analysis extension, right? So what we see is a lot of times for people, they have things like an over-reliance on physical prototyping, because you do need a way to verify your designs. Again, it tends to lead to longer development cycle times. It's really only done later in the development process. So that could be very costly if you go through multiple iterations. And what we see time and time again is projects being delayed or coming in over budget. Definitely things that we need to be able to avoid with our projects. And these are things that we set out to solve with the flow analysis capabilities that we have in Creo. And the goal is to build out an extension to take those CFD capabilities, put them into an easy to use tool that you have right from your CAD environment. We don't want you to have a heavy reliance on late stage prototypes or other type of verification techniques. Just make it part of your early, your mid, your late stage design process and start to get those results back early and often. And though this is a very robust and at the end of the day, a higher end package, we built it in a way that works for your standard Creo user, works within the same type of standard user interface, very user friendly. We want both the analyst and the standard Creo user to be able to work with this extension and really build it into part of the overall process of the design. And the workflow between design and CFD is completely seamless compared with your normal process that you might see with other tools where if you're working with a third-party system, you might have issues switching back and forth between your CAD and your analysis environments. So what we really wanted to do is break down the barrier that you typically see there between where you would normally have two different worlds of design and analysis. We want to be working more in one unified analysis-driven design environment. You're taking the results that you have from your flow analysis, using that to drive your design decisions. And likewise, whenever you make your design decisions, you're able to validate those type of decisions through the use of your flow analysis. We have a very easy flow creation model. For example, here we have the ability to tell the system to generate the mesh for our analysis automatically. You don't have to go through and define all that yourself. You still do have the ability to make the mesh more defined and have a little bit more manual control in areas that you'd like to. You have more curves or complex surfaces, but in areas with maybe more simple flat geometry, you can extend out that mesh, make it a bit faster to run through. And in general, just being able to automate a lot of that process so you don't have to go through and do that yourself. And along that train of thought, it was a very quick turnaround for getting the simulation results. You don't have to ship off the models to get back results in hours or sometimes even days. We don't have time for that a lot of the time. So let's just go ahead, get that analysis run through ourselves and get the results back much faster. And in conjunction with that speed, the results that we're getting back are highly accurate. We have many different ways of viewing the results, taking section views, creating XY plots, viewing ISO surfaces. I'm going to go through and show a lot of this, but with that, not only getting the results back, but getting it into a form that actually provides insight rather than just a bunch of data lying around that you have to try to sort through. We can really get that into a form that makes sense for the designer and really gives us that good insight. And here, looking into this, like Rob mentioned, we offer multiple different packages around this, depending on the level of detail or the different options that you might require for your processes. If you're someone that's going to be running flow analysis every single day and you're looking to get pretty much all the different capabilities that you might need to look into, we have options around that. But again, if you're just a standard type of user that wants to work into many of the different areas of flow analysis, you might want to work around the standard flow analysis package. So if you're focused on more of just the flow, things like heat transfer, looking for turbulence, you see here that the standard might be a very good option. One thing around this is that it is extremely affordable compared to a lot of the different flow analysis options that you might see out in industry. This is something that you can get up and running with very quickly and is not going to break the bank. Around that, we also have a plus package. If you want to analyze elements such as individual particles or radiation, this might be something that you might want to work with the plus package around. You can also, from that point, simulate the movement of individual particles. You can also animate on the analyses even while it's running. So that's something that can essentially update while you're going through and making changes or while it's refining the results. And then finally, if you're working on anything around dynamic models, multi-phase, multi-component systems, you'd want to utilize the premium package. So you get capabilities for cavitation, simulating fluids and solids interacting. This is really the complete fluid analysis solution that is going to cover almost any single case that you could think of or even dream of, and probably a lot more past that as well. And here I'll leave up on the screen just a few kind of overview so you can see what this looks like. A quick breakdown of the standard, the plus, the premium. This is something that you want to refer back to. You can take a screenshot here. I'll put it up after the demonstration as well. But that's what I want to do here as well, is go through and actually show a quick demonstration of what this tool looks like in the context of Creo, so you can see what that workflow looks like, how easy it is to run, and a little bit about that process. So with that, we can go ahead and switch into the demonstration. Again, if you have any questions, feel free to drop those in. We can take those. But for now, we'll go ahead and switch over. So going into this here for our demonstration of the flow analysis extension here in Creo, we're going to be working with our Polaris snowmobile data set. Specifically here, we want to get some information on a heat exchanger that we've been working on inside here. Go ahead and open up our parts. We can go get to work. And you can see that we have some pretty good geometry that we're going to be able to utilize for our study. We know that we're going to have water moving through this heat exchanger, and we can go through the process of setting this up here. Now, the first step that we're going to take whenever we want to go into a flow analysis study is just go right up into our applications and get into our flow analysis. It's just another tab that you have available. And once we're in there, we'll go ahead and start into a new project. And the first step would be to lay out our fluid domain for the study. A fluid domain is essentially the boundary for the simulation. It means that all the fluids within that study are all contained within a certain 3D space. The other thing that we can do is lay out a surface set that tells the systems where our openings are located. In other words, where the fluid is either entering or leaving the system. And then once we have our fluid domain laid out, there's obviously parts of the model where fluid is not going to be flowing through. So here we're just telling the system which parts of the model should be treated as solids and then excluded from the study. From there, we can go ahead and define the materials that we want to work with. So here we can see our fluid materials. You can see we have a lot available here. This is also fully extensible. So if you wanted to add to this fluid library, you could as well. And then the solid domains is the same that you're going to be working with anything in Creo. So you're going to be working with the out-of-the-box Creo solid materials, but then again, same as the fluids, also fully extensible as well. In this case, we'll leave that as aluminum. Right, next from here, we'll go ahead and look at the physics modules that we want to run for our particular study. So for our study, we want to go through and select on a few of these, maybe, for example, turbulence or heat and streamlines. What that allows you to do is really zone in on exactly the things that you want to study. So if you're not interested in seeing the particle flow or the streamlines, you don't have to look and you don't have to waste time simulating all that. You can speed up your calculations and really narrow in on exactly what you're interested in studying. All right, after this, we'll take a closer look into some of the conditions for our analysis. For our study in particular, maybe we want to see what our minimum and maximum temperature values are going to be. You'll also have options for what we want to plot for our outputs, which we'll see more of in a moment. But next thing I want to look at here is our boundary conditions. Go ahead and zoom in here on our inlet pipe. We can go through and enter in some of the values that we want to observe. We're interested in the inlet flux and the temperature. We can lay that out. And there's many different parameters I can go through and change here, just really tailoring the analysis to the exact case that I want to study. Able to do the same thing down here at the outlet if we'd like to. In my case here, I'm pretty much happy with the values that we have laid out. Around a general overview of the study, we also know things such as our exchange coefficient and the ambient temperature for our aluminum heat exchanger. Just very quickly go through and define some of those values. And once we have that all added in, we can define the mesh for our fluid flow analysis. Again, Creo actually builds out the mesh for our model automatically. We can just simply open that up and check that out. Make sure that everything looks good here for our mesh. We can take a look at that, review it, make sure that we like it. If we wanted to go through and make any changes, we could do that. But in my case, I'm happy. And once we have that all laid out, we'll just say what we want to show and go ahead and run the study. And you can see essentially, as soon as I click the button to run the simulation, we're getting data back from the study. I'm able to make changes to the animation style, put it into a form that best displays the information that I want to see. And looking at the plots at the bottom, we can see that our max temperature value has settled out just around 360 degrees Kelvin. And we can see here for each iteration that we go through, our plot information is being updated real time and starting to converge towards certain values. And we took about 3 minutes to set that up, and we're really getting results back that fast. We can see once we've completed the analysis, we can see the water is coming into the heat exchanger at its highest temperature there. And as it's moving through, it's cooling down by the time it gets to the outlet. So everything seems to be working as we intended. Now from here, we can go ahead and analyze some other outputs such as pressure. So we can see how that's changing over the course of the flow. Maybe we want to see the effect of temperature on the outer casing of the heat exchanger as a result of that flow. That really gives us some great insight, gives us a better understanding of what's really happening in that process. One of the useful tools that we have here is the ability to take section views of the results. Say we wanted to look at some temperature values inside of the model, we can move that to the X plane, check it out in the Y or over in the Z. Another powerful tool that we also have at our disposal during this is the ability to search for specific values throughout that simulation. First thing that we have is a slider bar that we can move from a minimum to a maximum. This allows us to see where exactly those values are located in the model. Also, if you wanted to see, for example, values at a particular point, say 345 degrees Kelvin, I can type that in and see exactly where that is here in the model. All right, so that's all pretty good for our first study. But now this is, again, going back to the point I made earlier, is what might happen is someone from my team or myself might be working with a new version of the model that we've been designing. As I mentioned earlier, we're likely going to be using this tool throughout the development of our parts or our assemblies. You can see this version here has more of a lattice type structure, which is very likely going to change how that heat exchanger is working. And now from here, instead of having to go through and set up an entirely new study, what we could do is just open up and utilize the one that we had just created. We'll first update the study to recognize some of the new geometry that got added into the model. We'll also update our surface sets around the faces of both the inlet and the outlet for the fluid flow, make sure that's updated. And finally, again, we'll hide the CAD bodies, utilize the mesh and the plots that we already have set up, and just like that, run back through the analysis. And again, you can see essentially as soon as we click to run the analysis, we're instantly getting meaningful data back. And we can change any of the properties to get our flow into a form that makes the most sense. And looking at the flow animation here on the model, we can see the lattice has definitely made a difference in terms of the direction for the flow, probably spread that temperature gradient out a little bit. And looking at our plot information, as we continue to go through more iterations, we're beginning to converge towards more accurate values for things like pressure, things like temperature, even the velocity. And it's going to go through and converge until our simulation study is complete. Right, and once the simulation is done, we have the ability to go through again, observe the flow a bit closer, click through to see any of the values or properties that we're concerned with. In this case, we could see exactly how that changes with our new design. And this could either be optimizing on the model. We could go through and try to see exactly what type of temperature values that we have. We could see here, now we've been able to spread out that temperature gradient a bit. So work with it from either way that you're interested in. Either do it as more of an optimization and design type workflow, or once you have things a bit closer to the finish, be able to validate on the decisions that you've made and make sure that everything is working as you've intended. All right, so that's all I wanted to cover there in terms of our demonstration, and really just wanted to give you an example of what that workflow looks like. Right, again, this works from many different areas, covers lots of different areas of that process, but you can see really around this, it gives you a lot of different value points throughout that. Really, what you're able to do is work towards more of that analysis-driven design. Right, you're able to run the studies early on in the design process. You don't have to ship it out to another system. You're breaking your dependence from late-stage physical prototypes. Even if you're able to save on just say one prototype in that process, that could be a lot of money for you, a lot of speed. And you're able to go through many more iterations earlier on in the process. You don't have to save them all to the end. You can really start to create and innovate at every step of the process, regardless of where you are. All right. So around that, I will also leave up the slide a little bit longer, just so you have a chance to check through, see exactly where everything lies in each of the packages. One thing that you also have available here as well is over on I'll say the engine that we work with is built out through our partner Cimerix. This is the team that works on and keeps on developing and improving this engine. That's another thing to mention here too, is that flow analysis in Creo is constantly being improved upon, being worked on, adding in so many different capabilities. So essentially every single release of Creo, you're going to see more and more capabilities around this as well. And if you're interested to see some of the examples of what's been built out with the tool, we have they have a website over at cimerix.com that has many different examples that you can check through, see exactly what this is capable of, and look at many different use cases that this could be used for. Okay, and with that, that's really all I wanted to go through and cover there. I can pass it over to you, Rob, if we have any questions, or leave it up to you to add any insight here as well.
Sounds good. Nice job, as always, Paul. So I'm going to share my screen. Yes. Here we go. So I want to thank everybody for attending today. But one of the things I want to, I guess, just reiterate, sometimes, analysis, whether it's FEA or CFD, can be a little, especially if you don't have somebody on staff now, it can be a little intimidating. And we have someone on staff here at 3HTI that is, I think, he's a foremost expert in finite element analysis and computational fluid dynamics. He's worked with a cell phone manufacturer. He's worked with lighting companies. He's worked with NASA on various projects. The guy's super smart and like lives and breathes this stuff. So we can help you if this, not only evaluate the software to see if it makes sense for you to purchase the software. Sometimes it makes sense to allow us to do the project for you, and then determine if it makes sense to purchase the software. So we're basically looking out for your interest, your best interest as a client, to help you solve a problem. Because sometimes it might be you might need to run CFD every once in a while, or you might need to run it more often. Whatever the case is, we want to make a recommendation that's going to, help your business and make the most sense. So we have qualified people that can help you. And also we provide 2 hours of desk side coaching for every license of Creo software that you have with us. Actually, it's 1 hour per license, but a minimum of 2 hours. But we, especially for new, if you're buying a new extension or buying Creo for the first time, we want to help your team get proficient at using Creo as quickly as possible. And, the old days, the old ways of training where somebody's out for a week and for 5 days in a training class, those days are gone. Because nobody has the time. You got to get up and running, and you got to get up and running quickly. So that's where we come in as a value-added reseller and a partner to help you become proficient, help your team become proficient as quickly as possible, and solve those issues. So this is my contact information, and you can contact me. You can send an email to info@3HTI if you have any other questions. And also, if you respond to the emails that were sent out, the invitations for this webinar, responding to those will come directly to me also. So feel free to contact me if you have any questions or need any additional information. Next week, our webinar is going to look at Unite technology. And one of the capabilities within Unite technology that I think is interesting that a lot of people may not know about, first of all, this is in your base package of Creo. So if you have Creo, you have it now. But you can also, we'll look at how to import other CAD files, how to open them within Creo, and also specifically how to save Creo as a SOLIDWORKS file, which is pretty cool, especially since a lot of our customers are using multiple CAD systems. So we'll look forward to that next week. So once again, thanks for attending. And Paul, thank you for a great job with the webinar, with the demo and the overview. Have a great day, everybody. Take care.